Now let us look about how to represent an irrational numbers on the number line. You already know how to represent a rational number on the number line. Yes, suppose I have to represent 2 by 3. What we do? We make the number of parts of each unit depending upon the number present in the denominator. So since the number present in the denominator is 3, so I will make 3 parts of each unit. So 1, 2, 3, 1, 2, 3, and the number at the numerator, that much you have to count, or that much number you have to consider. So 1, 2, so somewhere here is your 2 by 3. Okay, so this is how the rational numbers are represented on the number line. Now let us see how to represent the irrational numbers on the number line. For example, I have to represent root 2 on the number line. Now is root 2 an irrational number? Yes, definitely it's an irrational number. So the concept here tells us that if you have to represent an irrational number on a number line, you have to construct a right angle triangle on the number line whose hypotenuse is the number which is to be represented. In this case, I have to represent number under root of 2 on the number line. So I need to construct a right angle triangle whose hypotenuse should be root 2. So if I want the hypotenuse of the right angle triangle to be root 2, what could be the base and height? Will it be 1, 1? Let us check. What is the formula? Pythagoras theorem. Hypotenuse is equal to under root of base square plus height square. Here I have taken the values as 1 and 1. So square of 1 will be 1. Again square of 1 will be 1, which gives me under root of 2. So that is what I want. Yes. So now this right angle triangle, I have to construct it on the number line. Let us see how to construct. Let us draw a number line first. So 0, 1, 2, 3. This right angle triangle has to be constructed on the number line considering the base to be 1 unit whereas the height to be 1 unit, right? And it has this 1 unit base has to be counted from the origin. So this is 1 unit. Okay, so this is the base of my right angle triangle. How much height I want? I want the height also to be 1 unit. So whatever is the length of this 1 unit you have considered, the same length perpendicular height you have to draw, which is 1 unit. Now as you can see, my base is 1 unit as well as my height is 1 unit. So if I join this, it will be my hypotenuse, and the value of this hypotenuse is nothing but root 2. So the same right angle triangle, I have drawn it on the number line from the origin. Now I have to represent this root 2 on the number line. Still this root 2 is not present on the number line. It is present above the number line. So how can I project it on the number line? The step says you have to take your compass, keeping the pointer of the compass here and taking this much distance. So suppose this is my pointer, so I am keeping the pointer out here, taking this much distance, and I will be projecting this on the number line. So wherever it is intersecting the number line, that will be your location of under root of 2. Okay, so what we do for representing any irrational number on the number line, the irrational number which is to be represented, you have to construct a right angle triangle with the hypotenuse of the length which number is to be represented, and accordingly you have to find the base and height what it could be, constructing the same right angle triangle on the number line starting from the origin. When you get the hypotenuse, keep the pointer here, taking this much distance, just project that on the number line. So this is how you obtain the irrational number or the value of root 2 on the number line. What if I wanted to represent root 3? Yes, so here now my hypotenuse should be root 3. So in that case, What should be my base and height if I have to represent root 3 here? Let us see. If I take root 2 as my base and 1 as my height, check. Base square means root 2 square. What is square of root 2? It is 2. Whereas height square, that is 1 square. Square of 1 is 1. Addition of these 2 is under root 3. So it shows me that if I construct a right angle triangle with base as root 2 and height as root 1, I can find the root 3 as the hypotenuse of that right angle triangle, and once I get that hypotenuse, I can project it on the number line. Let us draw it. What base I want? I want my base to be root 2. See, already we have drawn the base, or already we have found that this much length is nothing but root 2. Okay, until and unless you find the root 2, you cannot find the root 3, because for the construction of a right angle triangle, I want the base to be root 2. So for drawing root 3, your root 2 has to be located on the number line. So this complete length is my root 2, so which becomes my base for that right angle triangle. How much height I want? Again, I want the height as the same length, that is 1 unit. So let us draw a perpendicular height of 1 unit. These two lengths will be same. Now join these 2 points. Now this becomes your right angle triangle with the hypotenuse root 3. Same concept. Keep the pointer here. Take this much distance and project it. It should definitely lie before 2. Why? Because if under root 4 value is 2, definitely under root 3 value will be less than 2. So before 2, it will intersect the number line, and wherever it is intersecting, that will be your root 3. So this is one way. What could be the another way? Instead of drawing this right angle triangle here, I can also draw the same right angle triangle here. Why? Because this is root 2 length, which I already have as my base. Just draw a perpendicular length of 1 unit and complete the triangle. Again here I am getting the same right angle triangle which I have drawn here. Yes, the base root 2, the height 1, definitely the hypotenuse would be under root 3. Keeping the pointer here, taking this much distance and project. Both will intersect at the same point on the number line. It doesn't mean that if you are drawing the right angle triangle here, so it will have a different location on the number line. No, both the points has to be intersecting on the same point. So you can draw, or you can represent it in two ways, either drawing the right angle triangle here directly on the number line itself, or whatever right angle triangle you have drawn first for root 2, completing the right angle triangle further, taking the distance and projecting it. Yes, similarly, what if you have to draw it for under root 7? Yes, for drawing under root 7, you have to draw a right angle triangle whose hypotenuse has to be root 7. So what could be its base and height? Let us see. Hypotenuse is equal to base square plus height square. Base is my root 3. What is square of root 3? 3. What is square of 2? 4. What is the addition? Root 7. So if I have to represent root 7, I want the base to be root 3. Now here base and height you can take interchangeably. Yeah? It is not necessary that the base has to be root 3 itself. I can take the height also root 3 and the base as 2. But then again, root 3, how will you represent as a height? You already know how to, or you already have represented root 3 on the number line. So it's better you take the base here itself, and that's why I have taken root 3 as the base, and then 2 I can take as the height. Now let us see. This complete length is my root 3. How much height I want? I want the height as 2 units now. So draw a perpendicular length of 2 units. Joining them, this length will give me root 7, and now project this on the number line, keeping the pointer here, taking this much distance. So somewhere here it will intersect. So this will be my root 7, or else I have root 3 here already. I will draw a perpendicular of 2 units. Joining this will be my under root 7. Keeping the pointer here, taking this much distance, project. So wherever it will intersecting, that will be your under root 7. So these are the different examples of representing irrational numbers on the number line. Okay, so I hope you have understood how to represent. The concept is you have to draw a right angle triangle with the hypotenuse of the length, which irrational number you have to represent on the number line. To find that as the hypotenuse, you have to see what could be its base and height, and accordingly you will be constructing that right angle triangle on the number line.